is more like a discussion, and it's on the importance of funding research. We have a panel of faculty members. We have Dr. Antonio Gonzalez, Dr. John Wallingford, and Dr. Calvin Lynn. And so the purpose of today's discussion is basically to talk about the importance of funding both applied and academic research. And so our panel will talk about that at first, and then we'll open up the floor for a discussion. And feel free to ask questions or make a comment.
Definitely. Do feel free to ask questions. And before we actually start off, just a little background info on the purpose of all of this and what gave rise to the topic is that recently there have been budget cuts to research. And as you know, the University of Texas is known for being a research institution. A lot of what happens here is research. And those of you in the College of Natural Sciences, you know that from experience in FRI and other programs that are very research intensive. So the recent budget cuts are prioritizing applied research over academic research. And we will get further into the definitions of that shortly. But the purpose of this is to discuss why all sorts of research should be funded and not just applied research should be prioritized. So to start us off, we're going to have Dr. Antonio Gonzalez start us off. So we're going to give him the floor whenever you're ready.
Thank you.
Okay, so like I said, my name is Antonio Gonzalez, and I want to thank you for inviting me. Particularly Juan for inviting me to be here. And so, like they mentioned, we're going to be talking about basic and applied research. And so, right off the bat, title slide here says basic and applied research, not basic versus applied research. Because right off the bat, the point I'd like to make is that drawing this distinct line between the two types of research is a little bit artificial and does not accurately reflect the relationship between basic and applied research. It's just kind of a false dichotomy in my mind. I think a lot of scientists would agree. I also want to mention to the rest of the panel, feel free to interrupt me at any point and chime in with your 2 cents or perspective on the things that we're talking about. So, just like you hear the term research and development, not research or development, or research versus development, it's research and development. So I kind of see that these terms as similar. Yes.
So Juan has mentioned a few times. He said applied versus academic research, and I think that's also a false dichotomy because you can have academic research that's applied, but you're also doing whatever you want. So just want to straighten it.
Yeah, that's true. So you will often hear that basic research happens at universities, and that's true. The tendency is that but there's a lot of applied research that happens at universities as well. So it happens in both places. And so once again, the two are married. They're not separate. You hamstring basic research, and you're ultimately going to have hamstring applied research. So just to orient ourselves, I thought I'd give some quick definitions. I got mine somewhere from the B&L laboratory side, the Berkeley laboratory side, where they handle this big on this. So basic research, or fundamental and pure research, is just basically driven by scientific curiosity, and the point is to expand, man's knowledge or understanding of fundamental principles of a given phenomenon. And so it includes questions like, how did the universe begin? What is the specific code of proof law, things like this. Whereas applied research is more typically thought of as, practical problem solving. The ultimate goal of the applied sciences might be to improve the human condition. And so examples of this would be, improved agricultural crop production, so biotechnology, treating or curing a specific disease, so on and so forth. So this is kind of one way to break down these definitions. However, again, the differences between these two are not always clear. It's not always distinct. The lines can be blurred. It's also very difficult to predict what basic research will yield and when it will yield it. So this, think of it as some kind of progression or continuum. You never know. It's hard to predict how close you are, maybe in what we consider a basic field. So it depends on your point of view. And you can, some, might ask the question, well, how long is it going to take before this basic research gets turned into applied research? And therein lies maybe another definition for how you define the two. And it also illustrates maybe a continuum. So if you're a few years down the road, maybe that definitely be considered applied. If you're 30, 40, 50 or more down the road, maybe that's considered basic. If you're somewhere between, where are you? Are you basic or you applied? So again, it's just kind of a continuum more than a dichotomous kind of a phenomenon. Okay, so I was asked to present some personal, experience or anecdotes, bring these things to bear on these topics. I mean, you can go on and give textbook examples of like really classic, clear-cut cases of where something basic turned into something really important down the line. But again, just to kind of give it a particular spin, I'll talk about kind of what I saw as an undergraduate or as a graduate student not that long ago, and continue to see as a researcher here on campus. So when I was a graduate student and still continue today, I studied a model organism called Rhabdomyces. It's the premier plant model organism. It's like a fruit fly or of the plant world. And it's been absolutely pivotal in our understanding of plant phenomena and even general eukaryotic biology. And so we studied things like, this is model organism research. And we studied the genetics behind cell fate determination, so how cells decide what they want to be when they grow up, so to speak. And the community, the Rhabdomyces research community, studies cell fate phenomena, as long as it's focused on this one particular highly differentiated cell of the epidermis that you've seen there on the far right, is electron micrograph of these individual cells are called plant hairs because they if you ever seen a fuzzy leaf, that's what they are. These projections of the epidermis, not a plant hair. And so this would have been considered, we were studying the genetics behind this, and since we're geneticists, we're looking for mutants, plants that don't make plant hairs or make modified plant hairs. And so, from genetic screenings and genetic studies, we have a cool array of like these tricomutes you're going to see over there. There's the normal one on the far left, and you see different versions of them. As we did this work, we began to identify genes that are important for making plant hairs. And so you're seeing here an experiment where we overexpressed one gene, one transcription factor, a regulatory gene. And you go from the normal situation there where you kind of see the hair separated out of the leaf to this plant that's just choking on it. And so this is what I would consider at the time and even now is very basic research. Because one attitude would be so like, what you're studying this one model organism of no economic significance. You're studying this kind of weird, quirky cell type, and you know all the genetics behind what goes into making the cell type in this one species of plants, and so what? Well, part of the answer is, well, it's just we're just understanding and unraveling mechanisms for how cells and organs differentiate. That's the so what. But this was being performed around 2001, 2002, these experiments. Not long after that, by 2006, this is from a publication in 2006, between that time, we were contacted by researchers in Canada that worked in agriculture and at an agriculture research center. And they wanted to collaborate because they thought they could use the genes from Rhabdomyces we cloned and characterized in this model organism and apply it to a crop species like canola to make canola carrier. And so what you're seeing is an experiment where you got a normal canola seedling over here on the left-hand side, and over here on the right-hand side, it's been genetically modified with one gene from a Rhabdomyces, and it makes them very hairy. And so the point of that is that these plant hairs are a defensive structure. And it's a natural plant defense against insect damage and insect herbivory. And so you can spare canola crops when they're young seedlings from a lot of this damage. They tend to take heavy damage when they germinate in the field. And one solution is to spray pesticides all over the crops. Well, the idea being here is that if you can boost this natural defense early on with genetic modification, you might spare the use of pesticides. Keep them from getting in the food chain. And this all happened very quickly, before my eyes. So I saw what was clearly basic research, and I had no kind of vision or scope as to. You always kind of hear these things in the papers, but we were quickly contacted, and this was turned into something. We've also been. This is another thing about basic and applied research. It fosters collaboration. If you divide the two camps and you think they're really different, that's not the case. So people will get in touch and start to are doing basic research, thinking about applied things. And so you get collaboration born out of this. These same genes from Rhabdomyces have been put in cotton to try to modify cotton plants. So we've been collaborating with, or used to collaborate with a guy from A&M who had the expertise to transform cotton. It was very difficult. Again, all Rhabdomyces work. Here's another example of some genes that we were playing around with when I was a graduate student. You do nowadays is you got one for this plant that's very purple, but it's genetically modified with one gene to turn on the human pathway. There are people who do a lot of applied biotechnology research focusing on these pigments because they are great nutritional value. They're powerful antioxidants, they have demonstrated anti-cancer effects. So again, all born from model organism research, basic research, and it's quickly been turned over into biotechnology efforts. And so, you know, it took me weeks to go on and on about all the stuff that came out of Arabidopsis. Even our understanding of cancer has been increased by studying Arabidopsis. Lately, there's something called the COP1 signalosome that is important in regulating tumor suppressors in humans. And everything we know about COP1 signalosome started in plants, in Arabidopsis specifically. And that paved the way to learn about it in mammalian systems. So again, you know, you can go on and on about these great examples of what came out of the model organism research, particularly Arabidopsis. However, despite all this, the NSF has planned to cut all funding to something called TARE, the Arabidopsis Information Resource Center, by 2012. This is an online website. It's the one-stop shop for Arabidopsis researchers. It gets something like 40 to 50,000 usages a month. Many tens of thousands of Arabidopsis researchers around the world utilize this. It's been indispensable in my work and the other people who work on Arabidopsis I know. Yet, the NSF decided to completely stop funding this resource. And there's been a great outcry. So go to their website and it says here, you know, dear TARE community, if many of you are aware, funding for TARE will end August 31st, 2013. So, which was a big blow, and I think had other people in different model organisms worried about why this. The USDA no longer funds Arabidopsis research. They used to. The NSF funding rates for Arabidopsis grants have plummeted. Just on our own work, we've noticed where, you know, the NSF, we used to be able to renew our grants regularly for many years, and all of a sudden we're unable to, and it turned out when we looked into it, the funding rate for the type of grants we were applying for went from like about 15% to about well under 10%, like 6%. Yeah.
Do you feel like, or is there a reason that the USDA or NSF have a reason for cutting Arabidopsis over other model organisms?
The USDA in particular has an explicit reason. They say they wanted to fund more crop science, which is, you know, more we apply for. So they stopped funding Arabidopsis projects and they only want to fund crop science projects. So that's the reason. Maybe they feel enough of this Arabidopsis business and let's turn it into something, which is one point of view. The NSF, I'm not sure exactly why they just completely cut off TARE. That was a very bizarre move. It was one that kind of sent shockwaves to the Arabidopsis community, just to stop funding it. Because the USDA no longer, we feel, we don't even know for sure, but you know, when we talk about it with other Arabidopsis, we feel the reason maybe Arabidopsis funding rates have plummeted in NSF is because all the people from the USDA are now applying to NSF, so it's gotten more competitive. And you know, like my former PI, Dr. Alan Lloyd put, you know, I'm not a gambling man. I'm going to take my money and Vegas and put it all on black or play blackjack because a 6% funding rate, you know, 6-7% funding rate. Why do we get out of bed? So it, you know, it's pretty low. NSF claims they fund 25% of all the grants they fund. Which, you know, when you look into it more deeply, they count all these grants that were like $1,000 to study this, you know, so like that number gets inflated. In our experience historically, our grants were like 15%, and then over the span of like a couple of years, it dropped from about 15% to about 6, 7, 8% funding. So. Did that research need eventually produce for profit? Yeah, that's where a lot of biotechnological innovations come from the foundation. So yeah, the problem is real, and I guess just I want to give you a feel for that anecdotally, just my own niche, my own part of the world. You can see these things happening, and we've seen them happening for a couple of years now. So I know the Obama 2012 budget is very generous towards science, but the Congress version, the one they're countering with, is not so generous. So hopefully, you know, there's probably going to be some middle ground struck, but hopefully it won't, you know, get some way. Because otherwise, the NSF and other funding agencies stand to increase their budgets based on that. So anyway, that's I think that's all I got. Now.
All right, I guess I'll start. let's see. So let me start by saying that if you read the papers, there's something called, I think it's called policy. Anyway, there's this movement to say, look, our universities are inefficient. Why are we wasting money on research that nobody cares about, technical reading and so forth? And so I guess I'm going to sort of start from that perspective. And these same people say, look, why are you even bothering to fund academic research? Because there's so much more research being done in the industry. And that's where, the market's driving it. So clearly it's got to be right, because the market is all powerful, right? So I guess the first thing I would point out is that I think that, again, the dichotomy between basic and applied, I don't really like those terms. I think to me the right term are long-term and short-term. I think Antonio hinted at this. Because if you look far enough away, you could be working on an applied problem and it looks like science fiction, and therefore it's hard to distinguish that from pure research, right? When Galileo's looking at the stars, he's not thinking, we're going to see how's this space show going to work. I mean, he's not thinking about the economic benefits of space exploration. He's just curiosity driven, right? In 1969, we put a man on the moon, but in 1969, we also had another pretty remarkable event, which was Jan Kleinrock at UCLA created the ARPANET. He had a whopping four computers that were incredibly slow, and he managed to send a message from one to another. He was just trying to send the words login, and then he got L out, O, and then the system crashed. Okay, so this is this terrible system, and at this point, I've got to say, this is pretty much curiosity driven. There's nobody that in the right mind is going to say, wow, with these four computers, we're going to make a lot of money, okay? And then we can't even actually get to communicate, right? And now we have probably 1 billion computers connected to the internet, and so much of our economy is based on it, right? So it's really a matter of short-term versus long-term. Okay? So now the question is, what's important to long-term research? And I think, again, the point is that long-term research, yes, it's not clear where it's going to go, but it can have a huge multiplicative effect, okay? If you do good long-term research, it spawns short-term research, okay? And typically short-term research is being done by companies, okay? And again, that was one example, but there are many examples of long-term research that turn into short-term research. So then the question might be, why don't we just let the market decide? And the problem is here's where government has to step in, because if you leave it up to the companies, they're going to do short-term research because that's going to help their bottom line and that's going to give them short-term payoff. In other words, I think short-term research makes money for a company. Long-term research, if it's done well, instead will create new companies, will create new markets, will create new industries, right? And that's not what the companies in the business are doing for the most part. So the point is that we absolutely need to have long-term research, and the majority of that's being done in academia. That's not to say we shouldn't fund short-term academic research, right? But I think that in general, academic positions tend to go further, and so that's what we're on that. Let's see, there's one more point over here. I guess just from an economic perspective, I mean, if you were to look at, say, the demographics of the United States in the 1800s and say, well, what percentage of the population is in agriculture? Does anybody know what the percentage is? I don't know. Let's say it's 50%, right? And if that's not right, then just go back a few years, okay? So at some point, a huge percentage of our population is focused on agriculture. We're producing food, we're raising animals and so forth for what we eat. And what's that number today? Does anybody know? It's a lot smaller. Yes, it's far less than 1%. So if we were just worried about jobs, we were politicians or artists, we might say, oh my God, in the year 2000, all our jobs are going to be gone, right? And we'd be worried. Well, what's the fallacy here? The fallacy here is it doesn't matter how many jobs you lose. It matters how many jobs you create, right? Same thing happens in the computer industry. Oh my gosh, we're losing our jobs in India. But the fact is we're creating so many more jobs than we're losing. So now the question is, how are we creating jobs, right? Are we just making more McDonald's, more people can work and sell burgers? No, we're creating industries and new innovation. Innovation drives the economy, basically, is my point. How do you get innovation? You get innovation through research. Okay? So from everything from national security to the economy, you need to have research because at some point, if you don't do that, you're going to wither away and die as a company and as a society. So, and I guess finally, as just a philosophical perspective, should we have the space program? I mean, I guess, again, my feeling is this. Part of what makes us human is this desire to just learn more and to sort of make progress, okay? And if you buy the view that long-term research is science fiction, but it's hopefully science fiction with a good heart and a good mission, then we have to keep doing long-term research, because that's just a reflection of how we dream and how we, make us human.
So I concur on all of these points. I can echo some of the things at the NSF, certainly the NIH, which is actually funding biomedical research. They fund great plant research, fund a lot more biomedical research. Same things happen. Funding rates have gone down from 20% down to around 7%. In large part, that's a budgetary issue. I'm sure that the NSF didn't decide to cut tear. There wasn't enough money. Something had to be cut. That's what was left, right? I mean, so and this is the case everywhere. And so it's a real problem in funding at the moment, right? If you're trying to pick the 20% of best grants, you can probably do that on merit, right? You can say, all right, this grant is terrible. This work will never get done. This grant is very good. But once you get up in the higher echelons of these things, it really almost becomes subjective, right? So you're sitting here and you're looking at two excellent grants, and this one is interesting to me, and this one is boring, right? And this one's biology, this one's computer science, right? There's other biologists, right? And so he's going to make a different decision than I am if objectively they're exactly the same grant. And that's the situation we're in right now. There's simply not enough money to go around. So I could sit here for a long time, but I think Tony did a great job of it, and sort of point to basic science research with no intention whatsoever to move into applied research that's going on to great things. An example I would give, and I'll do it very briefly, the cyclins, if you've heard of them, they're the things that help the cells divide. They're supposed to divide. One of the biggest important things. Cancer was discovered by a guy who wanted to know why all the cells in a clam embryo divided at the same time. Okay, he was working on a marine biological station, right? Essentially clam embryos. He got the Nobel Prize for that, right? Green fluorescent protein, the Nobel Prize a couple of years ago, is one of the most revolutionary technologies in all of biomedicine. It was discovered by a guy who wanted to know why these jellyfish glow in the dark. Literally, I'm not kidding. That is what he wanted to know. It was a jellyfish glowing in the dark. How'd that happen? He's got the Nobel Prize. Okay? So there's no question that these types of basic research lead to application. These types of short-term research gains get made from research with a very long-term vision. Usually it's different people. Usually, the guy who discovered this jellyfish glow, and he writes a little paper that gets published in an obscure journal. The guy who's trying to cure cancer reads that journal. And there you go. Same thing here. These these USDA guys read this paper. They say, oh, we can do this in canola, and now we make something out of it. It's clear that there's a hierarchy. But all of that said, again, I don't think I even need to make that argument. Hopefully, if you're sitting in this room, you're probably already convinced of that. It's a bit of a built-in assumption. What I think is a more important issue to deal with, and what I'm going to talk about for a few minutes, just to throw it out there, is why. Why do people? So it used to be sort of uniformly accepted. Well, those guys at Harvard are really smart. If they're studying it, it must be important, right? And then there was, when I started in college, there was never any question in my mind that if we generate knowledge and we learn things, this is good. Humanity is improved, and we're a better society for doing basic research. That attitude seems to be waning everywhere in the world, and I think in part it's waning because there's just not enough money, right? If you have to fund food stamps versus NSF research, it's a very tough decision to make. And I think that one of the things scientists do not very well is to communicate to the greater public what it is that we're doing and why we're doing it, right? I think quite frequently there's I could explain it to you, but it's really complicated and I'm kind of tired. There's a subset of people who say, no, I just couldn't even explain it to you, which I think is a bit of a lack of vision, but sometimes it's just true. But I think we have a real disconnect between between what we're doing and what the general population perceives of us as doing, right? I think the reason things get cut from the NIH budget is the NIH budget gets cut because not enough scientists talk about what they do at dinner parties. And here's the important way, in a way that makes sense to people, right? It's easy to explain that I study how frogs gastrulate, right? I can say, yeah, okay, you got the cells, they do part of this embryo, they go over this part of the embryo, and that's how the frog gastrulates, right? Why on earth would you give $100 billion of your tax money to me to study frog gastrulation, right? If, however, I say we're studying how cells move in frog embryos because we know through evolution that the same genes that control how these cells move in a frog also control how these cells move in a human baby. And when we do experiments on human babies, we get in a lot of trouble. But we really need to know what those human babies are doing. Then it begins to make some sense. If instead of saying I'm very interested in frog gastrulation, I say instead I'm using animal models for human birth defects, then suddenly it makes a little bit more sense. Now, part of this is cynical on my part. Part of this is I need to get funded, so I'm going to call it human birth defects research instead of frog gastrulation research. But the other part of me actually believes that. I think that the public in general would be happy to support my research on frog gastrulation if only I was able to explain to them that, yeah, there's an absolutely legitimate reason to suspect that what we're doing will make a difference. I don't know that it does. It's long-term research. It's fundamental, right? We really are getting out of bed in the morning to figure out how frogs gastrulate, but we genuinely believe that this will impact human biology. And moreover, we're thinking about it, and I think when money gets tight in particular, that we, across all fields, have a bit more, especially if you're taking taxpayer money, as most of us are taking NSF, NIH money, I think we have a bit more of a responsibility to spend a little time thinking. It doesn't mean, okay, I've got to stop doing this and I've got to start working on cancer. All it means is I think I need to spend a little bit of time looking at what I'm doing and how this might be relevant in the long term. It kind of sounds kind of cynical, kind of almost like a marketing campaign. And to some extent that's true, I admit that. But I do also think that it really matters. And what I've done since in my own experience, since beginning to think this way, is I'm finding myself more and more involved in clinical research. More and more people are contacting me as I begin to write a little bit about the parallels between what we're doing in human biology. I'm finding that physicians who work on these syndromes are sending me emails. They're talking about their same kind of experience. And so I think the point that I would add is just, I think a really important one is that part of, so yes, it's important to fund research, but I think it's also important that researchers communicate better what they're doing to the people who are giving them the money. And I think this impacts everything we do. And since you guys are all college students in the natural sciences, you're moving forward, might have careers in science. I'll leave you with one of the greatest things that I heard ever in a seminar was from a guy, I wish I could remember his name. He was one of the White House science advisors in the Clinton White House, came and gave a lecture when I was at Berkeley as a postdoctoral fellow. And he said that if you're a scientist, it is your job every time you sit down next to a stranger to try to explain why what you do is important. And if you just make that your job, every time you sit down on an airplane or at a dinner party with someone, don't be a jerk about it. Just sort of, if they ask you what you do, don't brush it off. Take a moment, think about how you're going to explain to them what you do and why it matters, and then do it. And I think this is really good advice. I think I'll end with that.
So if anyone has any questions or comments, please feel free to discuss.
Front row.
I saw, yeah, again, well, I think you
What is the difference in the amount of funding that research is receiving now versus the university?
So it fluctuates year to year with the budget, like Tony was saying. In the past several years, the NIH increases have been less than the cost of inflation. So the amount of money the NIH has to do relative to the amount of stuff it'll buy is actually decreasing over the past 4 or 5 years. That being said, in the 1990s, the NIH budget doubled from 91 to 98. So there was this massive doubling of the amount of research being done, and it sort of leveled off from there, just dipping down lower and lower. And one of the things that's most concerning, I'm less concerned about the 2012 budget than I am about the thing, the committee that was formed, that if they can't agree on the budget, this committee gets to select, there are all these draconian rules that happen. Well, one of them is that all discretionary funding is on the table, and the entire NIH budget, billions and billions of dollars, falls in discretionary funding. So it is conceivable that a small group of people could decide to eliminate the NIH from the United States budget next year. And if you are worried about science, that's fine, but if you're worried about, I employ 13 people in my lab, and I'm one of billions of people who are funded by the NIH, it's a staggering and terrifying thing. The NIH is very good.
NSF has also been fairly flat lately, so effectively they're not keeping up with the questions.
How can scientists improve their communication in science media? Because on the one hand, you have studies that come out and media can make fun of them about how millions of dollars are wasted on something, perhaps because it wasn't explained how what the purpose is. But on the other hand, you have a bunch of press releases that come out that promise things that are very unlikely to ever get developed. So what balance, and how can we improve sort of communicating and not overstating?
Yeah, well, I was going to say, I totally agree with not 1% here, but I mean, cynical. When I was a graduate student, and even living today, so that I have a hard time handling questions. So what good is this? Like, what are you going to do with this? And they're just going for all I got better and realized, okay, I got to spin this. It doesn't help either that you got people in prominent places with big platforms and loud voices, like Sarah Palin, who, what was it, a couple years ago, came out and said something like, all fruit fly research is utterly Republican. And then threw in, like, it happens in Paris, France. Like, then threw in that, like, to disparage it even more. Like, what an asinine, idiotic thing to say. So, we gotta get better at communicating. And then the proponents who just say whatever the hell they want to sabotage, scientific research. How do we combat them as well? And so you're right, you see press releases that say so research is going to cure diseases, AIDS, and how do you kind of grapple with that? One way is just to be really savvy, a really savvy, consumer, savvy citizen. Besides that,
I sort of have three ideas. First of all, everybody talks to other people, and you can learn how to explain the science that you know as right to anyone, and you got to knock back down from it. I tried it out on my parents. If I can't explain it to my parents, I'm not doing it right. And just say, okay, here's what I want to do, and then ask them, do you think that sounds important? And if they don't, then you haven't done your job, right? So try it out with your parents. Talk about the science. Try to understand. Try to explain to people you know, right? And kind of get it together. And then I have a pitch on my work. I have the elevator pitch. And I have the airplane seat pitch on my work. This is what we do. And then you just have to be sort of assertive about making that known. You can't let stupid statements lie at dinner parties and places, and everybody has a chance to do this on a small scale. Two, if you're so inclined, try to move to the bigger scale, right? I'm not a very political person. I don't write a lot of letters to my congressman. Too bad when the NIH budget's coming up for a vote, my congressman gets a letter, right? So you can get involved, right? FASTA, and so the American Association of Anatomists, several of these groups have sort of media arms. American Society for Cell Biology has a media arm. You can join these societies and get involved in their sort of media arm and do that way. The last thing I would say is education. I think a main problem, right? So, I've got a paper submitted right now where we did studies in yeast that predicted genes that would be involved in blood vessel development. Yeast, obviously, single cells don't have blood vessels. We tested that in frogs. It turned out to be right in frogs. We went back to yeast. We did some computational stuff. We came up with a new drug, which we tested in frogs. we've tested in mice, and now we're writing grants for clinical trials because we think it's cancer therapy, right? We're able to do this because evolution tells us that genes work together and do similar things. So education is the other point, right? Of course, we're all going to stand up and say teaching evolution is good, but you have to explain why, right? You can't just say, look, it's not about the Bible and right and wrong. It's about if you want to do good biology and cure cancer, you need to have this fundamental grounding in evolution. And so you can get involved in education, go get teaching. I don't think enough is done to push students to give a crack at teaching. I'm here because I had a fantastic teacher in 7th grade. She retired after 30 years. But I've been keeping track of her, sending her reports on my progress. I can't thank her enough. I don't know where I need to go teach.
Okay, so you said that the issue lies in funding long-term versus like short-term research. And were you supposed that the types of research occur? Because you said that companies prefer to do short-term research because it's more immediately profitable and it's basic market, like more stable, I guess. And how would you find the right balance of like where you do short-term research and long-term research? Like, would you do short-term in companies and then long-term in like universities? How do you know where to do one?
Well, I mean, that's kind of the model we have now, right? What we do now is there's a bunch of long-term research, and when somebody sees how it can be applied somewhere, then they go jump in and say, hey, I can make money this way, or I can get a better drug this way, or whatever it is, right? So at some point, in some sense, at the short term, the market forces do kind of work. Right? It's at the long term where it's risky. That who wants to, risk in the long term, and also the reward in the long term is short term, right? There's been claimed that we ought to evaluate our faculty based on how many patents we create, right? Well, that's crazy. That means that that sort of implies that the only research that's good is the one that creates a patent, right? Whereas you can do something fundamental, which will lead to a million patents, and none will be right? Because people follow your footsteps and they'll create them, right? So, yeah, I don't know what the right answer is. I know we have to have a mix, and I think that to some extent, the market kind of drives the short-term research, right? That's why I think the focus has to be on funding. I don't know if funding is.
No, I agree, and I think the mix sort of comes organically in a place like the University of Texas that, until very recently, has really valued top-tier research. And again, it goes sort of the dichotomy is not as stark as it seems, right? So the NIH offers several different types of grants that are only eligible for them if you have a commercial component and also an academic component. So there are grants that are specifically for someone in a business and someone in an academic setting. There's others that are specifically for small businesses. You can only get them if you're a small business collaborating with the university, right? So the continuum is complete. There are the people who really care nothing but, sea urchin embryos, right? There's people who are sort of their hands in everything. The continuum is very wide and it covers all the bases. And so I think it sort of it comes organically in places where research is fostered. It does require fostering research from the administrative side of the university, though. If we're not, the administrative side is not supportive of that research, we'll go elsewhere.
Any other questions?
So I have a question about some So, like for example, funding this type of analysis, would it be possible for you to transfer that research to another organism, or would that look like
So
what we found?
you're saying, you're asking if cut is going elsewhere?
Yeah,
So you could work with biologists if you transfer your knowledge to some other non-organism. It's a big hit.
Yeah, right. So the amount of infrastructure that's kind of built around our offices is enormous. It's staggering. I mean, that website is kind of, it's all about it. For decades, or maybe not decades, the website itself is not all that old. But for at least 10, 12 years now, people have plugged in all their research they're broadening it. And as data becomes more at large scale, with like genomics type of data, and large scale districts. They all get dumped in, they won't be in line. So at this point, I don't think it's very feasible because we should disagree on two different. There have always been other platform organizations, but this one just kind of emerged among all the ones at the time. Go back over the Parliament and Tunia and other things like that. Snapdragon, there was a time when we were working on a lot of different plans, and then all of a sudden this one kind of emerged. I think the view is just an excellent representative, it fit all the criteria, and very rapidly large infrastructure.
That's the infrastructure that makes the model system worth working on, right? I mean, I pick a certain species of frog, not because I'm interested in frogs, but because the kinds of experiments I want to do are well supported in there. That's one of the main things. I don't know if there's a corollary. I guess there are models that you program in versus other.
Well, I mean, this example of the ARPANET, it's a model, right? And right now we do research in artificial intelligence, and we got these really simple systems, and that doesn't look like doing it, right? But over time, technology changes, and more innovation, so they can more organism. So yeah, we have the same. You can kind of go faster.
You've
Go faster.
got a better foundation.
Yeah. But by the way, I think it's a great question because I think a lot of people don't understand that what's important about this smart organisms. This particular one.
Yes. So if we assume that the funds are, all the budgets are constant, that those aren't going to change, and so funds have to be cut somewhere, what improvements do you think can be made to how decisions for grants are made?
This is a good question. I think people don't understand how grants are awarded. Actually, I'm not that familiar. In fact, I'm not familiar with NIH. NSF is actually a pretty good model. It's all peer reviewed. So you get experts in the area making decisions. And, that's obviously sometimes you get bad reviewer, but for the most part, I think it's a really, really good system. So that you really reward excellence rather than, oh yeah, this person's Department of Texas, they're from the funding, right? So I don't think that answers your question, but I think that's a good system. For example, there's a lot of funding for the military, ARPA, DARPA, whatever, that's Department of Homeland Security, where it's not peer reviewed, it's some program manager has some buddies and asks his buddies, which one do you like? And sometimes, they fund new research, but I don't think it's as good a model. And they fund it by money. Maybe it's important.
I think right now, NIH model is very much the same. It's peer review. I think it's generally a good model. I think the problem is that if you have enough money to fund 20% of your grants, it's a pretty good model. If you have enough money to fund 7%, you really get into a place where it becomes very subjective. And so I don't have good answers on how to fix it. At the moment, there's just not enough money, right? And so, when the decisions get really, really hard between this fantastic science or that fantastic science, it's very difficult to be effective. People talk about limiting the number, the amount of NIH money that any one lab can have. But I'm not so sure that's great. There are some labs that I think the more money you get, the better stuff you get, right? And that will continue exponentially. If you've heard about it, I think it's exactly just people money, right? Either the economy has to get better or the society has to decide it has a higher value than it is in any place.
By the way, the other thing I'll point out is it's not just the funding level keeping up with the cost of living, right? The population is growing. The number of researchers is growing, right? So in some sense, we actually want to kind of keep up with that as well. So even if we kept up with the cost of living, it still wouldn't really be keeping up in some sense, right? And that's what we want to say. Over time, the percentage of people doing research should go down. That's the model, then that's okay.
Is government research funded by sort of deciding a set amount in terms of dollars, or they do it as sort of a percentage of total revenue?
They have a budget that's dollar amount.
The appropriation for the NIH and then the NIH director and all the other people decide how to make it.
Right, but do you think it would be one sort of solution would be to just set a certain percentage of revenue so that it sort of keeps track naturally with.
Oh, I see.
I don't think anyone would ever allow that. You would have to cede control. Politicians don't ever do that. I don't think they would, then they couldn't make their money back, right? So the problem is, how many dollars are you gonna return on the investment that you made in my podcast or basic research? You're not gonna know for 100 years, right? It's gonna be very different calculation. The problem, the real problem that we face, and I think this is true in computer science, or anything, you know, say there's a crisis, take AIDS for example. Plastic item didn't exist, and suddenly in the 80s it does exist, it's killing people right and left. Aren't you glad that pointy-headed guys in little glasses were studying viruses for 200 years? I am, right? And there was a basis for, which was SARS. It's even better now, right? So genomics, God, do you really need to sequence 6 billion base pairs a second? Well, when SARS happened, you sure as hell did, right? And we didn't know where this came from. The H1N1 flu last year, you get on top of that, right? So all of these things, from people who are just like, well, we can see what's in the air a little faster than you see what's in the air. You just don't know, right? So something else could come along, something with the power grid, a new epidemic could come along, and there's going to be a group of people who have been studying this, and nobody cared, and Sarah Palin was buying it. And then, hey, you know what? They got the answer, right? So they're making an investment in the future, but you don't know about your
I mean, so yeah, I don't think it's intense, but no, I don't think it's countries. There are countries that don't do this. Look at Europe, they have very small budgets.
Yeah, we got to decide again as a society, and we have consistently decided either the right and left, both think it's important. The problem is the decisions are getting what they are, because the money's just not there.
Are there any more questions?
All right, thanks for your time.